Hey everyone, and welcome back to AI Paper Podcasts. Today we're diving into something that I think we've all thought about when working with LLMs. That is, how do we make sure that these LLMs can back up their claims with solid citations? And that's exactly what this paper is about. It's called SelfCite, Self-Supervised Alignment for Context Attribution in Large Language Models. And it's got a ton of insights that I think could really change the way we think about citation generation in LLMs.
Yeah, it's really a cool approach, and it really gets to the heart of this whole problem of hallucinations, which can be a major roadblock for LLMs, especially in these technical applications where you really need to be sure that what they're saying is correct.
Right. Okay, so let's jump right into the key takeaways for our viewers who are short on time. This is our 1-minute summary for the short form edit.
So imagine a world where you can train an LLM to cite its sources accurately. And you can do this without the need for, tons and tons of painstakingly labeled data. Well, that's precisely what SelfCite enables. It uses a self-supervised approach. And that basically means that the model learns to evaluate its own citations. And it does that without relying on human annotated examples.
So it's kind of like it develops its own internal fact-checking mechanism.
Exactly. Yeah. So the real core of this is something called context ablation. And that's a technique where the model actually removes or isolates, cited sentences. And then it looks at how that affects the probability of it generating a certain statement.
So it's kind of like testing its confidence, right? To see if the claim still holds up without the cited evidence.
Exactly. That's a great way to put it. And through this process, it actually generates something called a self-supervised reward signal, which basically tells the model how, important and how relevant each citation is. And a high reward means the citation is both necessary and sufficient to support whatever statement it's making.
And that reward is then used to kind of guide the model towards generating better citations in the future.
Exactly. So the paper looks at two main strategies for actually using this reward. The first one is something called best of n sampling, and that's where the model will actually generate multiple candidate citations for a statement. And it'll pick the one with the highest reward. So it's picking the best source from a pool of options. And the second strategy is preference optimization. And this is where they use a technique called Sympo to actually fine-tune the model to produce better citations based on these self-generated preferences.
So it's not just about picking the best from existing options. It's also about learning to generate better options in the first place. This is really cool, especially for researchers and engineers who need to be able to trust the information that their LLMs are providing. No more spending hours manually verifying sources. Okay, so now let's get back into the full deep dive.
Yeah, so the paper starts out by kind of setting the stage. We all know that LLMs have this tendency to make things up, those pesky hallucinations that we've talked about. And the traditional way to try to combat this is with citations, but that requires costly human-labeled data.
Right, which is a major bottleneck for a lot of projects.
Exactly. So what SelfCite proposes is a totally different way. And they draw inspiration from techniques that are used in model interpretability to basically help the LLM understand, the why behind its citations.
Okay, so this is really interesting. So walk us through exactly how SelfCite works. What are the actual steps involved?
Sure. So it all starts with that context ablation that we discussed. And they use two key metrics to figure out how good a citation is: the necessity score and the sufficiency score.
Okay, so break those down for us. What exactly do these scores measure?
So the necessity score, sometimes it's also referred to as the probability drop, that basically measures how much the probability of the LLM generating a statement decreases when you remove the cited text. So a large drop means that citation was, really essential for making that claim.
So it's like a measure of how much the LLM is actually relying on that particular piece of evidence.
Yeah, exactly.
Okay, that makes sense. What about the sufficiency score?
So the sufficiency score, or the probability hold, measures whether the probability of generating the statement remains high, even when you only keep the cited sentences. So if it does, then that means that the citation pretty much captures the essence of the reasoning behind the statement.
So it's like isolating that crucial piece of evidence and seeing if it still holds up on its own.
Yeah, that's a really great way to put it. And then SelfCite actually combines these two scores into a single reward signal. And a higher reward means a better citation, one that's both necessary and sufficient.
Okay, this is a really elegant approach. So, how does SelfCite actually use this reward signal to improve, the citation generation?
Yeah, so they explored two main strategies. We kind of touched on them before. So the first one is best of n sampling. And that's where, the LLM generates multiple potential citations for a statement. And then it uses the reward signal to select the candidate with the highest score. So it's basically choosing the best from a pool of options.
It's like it's having its own little internal competition for the best citation. I like that. So, what about the other strategy?
Yeah, so the other strategy is preference optimization, and that's where they use this technique called Sympo. And this actually goes beyond just picking the best from, existing options. It uses this self-generated preference data to actually directly fine-tune the model, and that teaches it to generate better citations from the ground up.
So it's kind of like Sympo is like the LLM's personal citation coach, right? Helping it, refine its skills over time.
Exactly. And this is where we really start to see the power of self-supervision, right? It's not just mimicking human-provided examples. It's learning to develop its own internal criteria for, what makes a good citation.
This is really fascinating. So, I know we always have to ask, does this actually work in practice? So did the researchers actually put this SelfCite to the test?
Oh, yeah, they definitely did. They evaluated SelfCite on the LongBench-Cite benchmark, and that's specifically designed to assess the quality of citations generated by LLMs. And they compared it against several really strong baselines, including prompting, large language models like GPT-4 and Claude and GLM, as well as another context attribution method called context-cite.
Okay, so they really put it through its paces. So what were the results? Did SelfCite, live up to the hype?
Yeah, the results are they're quite impressive. SelfCite actually significantly outperformed most of those baselines, and it achieved much better citation quality in terms of, recall and precision and F1 score. And here's a really important point. It was able to achieve all this while producing shorter citations than some of these, massive proprietary models.
So it's not just about citing more. It's about citing smarter.
Exactly.
That's great for efficiency and accuracy.
Absolutely. And then they also looked at a fully self-supervised setting where SelfCite was applied to a model that was initially trained on automatically generated citation data using context-cite.
So it's kind of like a two-stage process, right, where you're using one method to kind of bootstrap the other one.
Exactly. Yeah. And while the initial results in this setting were decent, applying Sympo actually boosted the citation quality even further, which really highlights the potential of these self-supervised approaches to achieve high performance even without relying on any human annotations. And really importantly, they found that answer correctness wasn't significantly impacted by this Sympo fine-tuning.
That's really good to know. So you're getting better citations without sacrificing the accuracy of the underlying information. This is really exciting stuff. Now, I know there's a lot more to unpack in terms of their analysis, right?
Oh, yeah, for sure. They actually did several really in-depth analyses to understand what makes SelfCite tick. For example, they did an ablation study to see how different components of the reward design contributed to the overall performance.
So they were really trying to pinpoint what makes SelfCite so effective.
Exactly, yeah. And their findings really underscore the importance of considering both necessity and sufficiency when you're evaluating citations. They also explored this really common challenge where models tend to learn to just generate longer citations, thinking that more is always better.
The classic quantity over quality trap.
Exactly. So to combat this, they actually introduced a really clever length balancing technique to make sure that the model focuses on selecting accurate and concise citations rather than just citing, tons and tons of text.
So they're really making sure that the model isn't, taking any shortcuts. This is all incredibly insightful, but I'm sure our viewers are eager to see, some specific examples. Did the researchers share any, concrete cases that illustrate the impact of SelfCite in action?
Yeah, for sure. And that's actually where we'll pick up in part 2 of our deep dive. Welcome back, everyone. So before the break, we were just about to, dive into some specific examples that really show, how powerful SelfCite can be.
Yeah, I'm really excited to see how this plays out in practice. I think examples are always a good way to solidify my understanding of, complex concepts.
Oh, absolutely. So in one really compelling case, the task involved generating, a response that actually required drawing information from multiple sentences. And these sentences were kind of, scattered throughout the provided context. And the baseline model, using its standard sampling approach, it actually missed one of the essential sentences. And to make matters worse, it even included one that was completely irrelevant.
Ouch, that's that's like a double whammy. You're missing crucial evidence, and you're adding noise to the mix.
Exactly. But here's where SelfCite really shines. With its, best of n sampling strategy, it was actually able to correctly identify all the relevant sentences and exclude the irrelevant one, all thanks to that, finely tuned reward system that we talked about.
So it's not just about finding a needle in a haystack. It's about picking out multiple needles while ignoring the distractions.
Yeah, precisely. And, to be fair to the researchers, they didn't just cherry pick, examples that made SelfCite look good. They actually also included instances where, the baseline model performed slightly better. So it was a very balanced and transparent evaluation.
Yeah, I think that's really crucial for building trust and credibility in any kind of scientific research. It's about acknowledging, the strengths and limitations of any new approach.
Absolutely. So let's shift gears a bit and talk about some of the other really interesting aspects of the paper. One thing that really intrigued me was their analysis of, how SelfCite handles the challenge of evaluating a commercial API, like Claude Citations.
Right. I was wondering about that too. How do you compare your method to essentially a black box system, right, where you don't even know the inner workings?
Yeah, that's a great point. And they took a really pragmatic approach, recognizing that they couldn't, directly compare the models themselves. They focused on evaluating the outputs of the Claude Citations API on the same LongBench-Cite benchmark that I used for SelfCite.
So it's kind of like saying, we don't know your secret recipe, but let's see how your dish tastes compared to ours.
Exactly. And what's really remarkable is that SelfCite, using a much smaller 8B model, actually achieved comparable results to this commercial grade API that's specifically, designed for citation generation.
That's really impressive. It says a lot about, the potential of self-supervision to compete with these massive, resource-intensive systems. Smaller models, less data, comparable performance. That's a win in my book.
Yeah, for sure. Now, let's talk a bit more about that fully self-supervised setting that we touched on earlier. Remember, they used a method called context-cite to actually generate the initial training data for SelfCite. And I have to admit, I was initially a bit puzzled by this. It's like using one method to kind of bootstrap another.
Yeah, I had the same thoughts, like, methodception.
Right. But, if you think about it, it actually makes a lot of sense because context-cite relies on this idea of contributive context attribution to figure out which parts of the context are, most responsible for the model, generating a particular statement.
So it's like identifying the key pieces of evidence that support the model's claim.
Exactly. Yeah, and they achieve this through a really clever technique involving, random context ablations. So they're basically removing different parts of the context, and then they observe how that affects the probability of the LLM generating, the same response.
So it's like they're poking and prodding the LLM.
Yeah.
Trying to see what makes it tick.
Yeah, exactly. And through this process, context-cite actually assigns a score to each sentence in the context, indicating how much it contributes to the response.
Okay, so they have these scores, but how do they actually extract citations from them? There's got to be more to it than just, picking the highest scoring sentences.
Yeah, you're absolutely right. There is a bit more nuance to it. So they use, kind of a multi-step heuristic process. So first, they actually filter out any sentences with scores below a certain threshold. So it's like they're weeding out the weak evidence.
Makes sense. Only the strong survive.
Exactly. And then they merge any adjacent sentences that, that pass the threshold, creating a span of, relevant text. It's like they're grouping together the pieces of evidence that, that belong together.
Sort of see how this all comes together.
Yeah, and then after that, they normalize the scores, converting them into probabilities. And finally, they use a combination of top P selection and top K filtering to choose the most probable and relevant citations.
Okay, I'm not familiar with those terms. Could you explain those a little bit further?
Sure. So top P selection basically involves choosing sentences until a certain cumulative probability threshold is reached. So imagine you have a bed of marbles, and each marble represents a sentence and its associated probability. You basically keep drawing marbles until the total probability of the marbles you've drawn exceeds, a certain value, say like 80%.
So you're ensuring that you capture the most likely citations while also setting a limit to avoid, citing too much text.
Exactly. And then top K filtering is a bit simpler. You just select the top K sentences based on their scores, regardless of their probabilities. So combining these two techniques allows them to kind of strike a balance between, capturing the most likely sources of information while also avoiding excessive citation length.
Okay, that makes sense. So they use this context cite method to generate the initial training data for SelfCite, kind of giving it a starting point for learning how to cite correctly.
Exactly. It's like, giving SelfCite a set of training wheels before it sets off on its own, self-supervised journey.
Okay, I like that analogy. So going back to the analysis for a second, I remember you mentioning that they also looked into the impact of different training data sizes for the preference optimization stage using Sympo.
Yeah, that's right. And what they found is that while more data generally helps up to a certain point, of course, using too much data could actually be detrimental to the model's performance.
Yeah, the classic case of overfitting.
Exactly, where the model becomes too specialized to the training data, and it doesn't generalize well to, new examples.
Right.
And they found that kind of a sweet spot of around 2,000 examples worked best for their particular setup.
So it's a good reminder that, more isn't always better. It's about finding that optimal balance between, data quantity and model generalization.
Absolutely. And, they didn't stop there. They also explored different approaches to preference optimization itself, comparing Sympo to a simpler method of just doing supervised fine-tuning on the best of n responses.
So instead of using those, paired comparisons of good and bad citations that Sympo relies on, they just fed the model the best citations directly.
Exactly. Yeah. And even though that approach did lead to some improvements, Sympo, with its, sophisticated use of preference data, still came out on top.
It seems like those paired comparisons really force the model to kind of learn the subtle nuances of what makes a citation good or bad. It's not just about mimicking the best examples. It's about understanding the underlying principles.
Yeah, you hit the nail on the head. It's all about that deeper level of learning. And speaking of pushing the boundaries of learning, they even experimented with an off-policy approach where they intentionally introduce noise into the citations and tried to train the model to to denoise them, almost like teaching it to spot and correct its own mistakes.
That's a fascinating idea. Did it work?
Unfortunately, not as well as they'd hoped. It seems like the type of noise that they introduced wasn't really representative of the model natural error patterns, like trying to teach someone to fix a flat tire by showing them how to change a spark plug. The skills don't quite transfer.
So it's not just about learning to fix any error. It's about learning to fix the errors that it's actually prone to making.
Exactly. And this actually leads us to one of the most, intriguing findings of the paper, this concept of iterative preference optimization.
Okay, yeah, I remember you mentioning this earlier. This is where things get really, meta. It's like the model is using its own improved output to learn even more.
Exactly, yeah. So they found that by repeatedly fine-tuning the model with Sympo and generating new training data, based on the improved model's output, they could achieve continuous improvement over multiple rounds. It's like this, a self-reinforcing cycle of learning and refinement.
That's really powerful. So instead of relying on a fixed data set, the model is constantly pushing its own boundaries and raising its own bar for, what constitutes a good citation.
Absolutely. It's a real testament to the potential of self-supervised learning to, unlock new levels of performance and adaptation.
This has been an incredibly, insightful discussion so far. I feel like we've covered a lot of ground. From the technical details of context-cite to the impressive results of SelfCite on the LongBench-Cite benchmark.
Yeah, I agree. We've really delved into the the nitty-gritty of how this method works and why it matters. But there's one more crucial aspect that we need to explore, and that's the broader implications of SelfCite beyond just the realm of citations. And that's actually where we'll pick up in part 3 of our deep dive.
Welcome back to AI Paper Podcast. I have to say I'm even more excited about the the potential of self-supervised learning after diving into SelfCite.
Yeah, it really is a game changer, especially for those of us who are in the AI research and development trenches, so to speak. I think this paper really underscores how powerful these techniques can be.
Absolutely. So before we dive into the broader implications of SelfCite, I wanted to circle back to those qualitative examples that we were discussing earlier. I think they really brought the impact of SelfCite to life.
Oh yeah, definitely. Seeing those concrete cases where SelfCite really outperformed the baseline model, I think it really drives home the point.
Yeah, I especially like the example where the baseline model missed that crucial sentence and included an irrelevant one, while SelfCite's best of in sampling nailed it perfectly. It's a scenario that I think we've all encountered at some point, digging through research papers and trying to figure out which sources are truly relevant.
Yeah, that's a great example. I think it perfectly illustrates the power of SelfCite's reward system. By carefully assessing both the necessity and sufficiency of each citation, it's able to guide the model towards selecting the most accurate and concise evidence.
Like having a built-in research assistant that double checks your sources for you. Now, I know the researchers also included examples where the baseline model actually did a slightly better job. So I'm curious, why would they highlight those if they're trying to showcase the strengths of SelfCite?
It's a great question, and I think it speaks to their commitment to transparency
and
scientific rigor.
In any kind of research, it's important to
acknowledge both the
strengths
and the limitations of a new approach. So including those instances where the
baseline performed
better and perform better. It shows that perfectly. It's a step in the right direction. But there's still room for improvement.
Yeah, that definitely makes sense. It it builds trust when researchers are upfront about the areas where where their method still needs work. So where do we go from here? What are the potential next steps for research in this area?
Well, that's where things get really exciting. The authors of the paper actually outlined several promising directions for future work. Yeah. One area they highlighted is exploring the integration of other alignment algorithms to the SelfCite framework. So while Sympo showed promising results, there might be other methods out there that could unlock even greater performance gains.
It's like having an ever-expanding toolbox. Techniques.
Optimizing LLMs.
Exactly. Another area they pointed to is improving the the self-supervised aspect of the initial supervised fine-tuning stage. Remember, they use context-cite to automatically generate training data. But that method still has some limitations.
So the the quest for a truly end-to-end self-supervised approach continues. Yes, finding new and innovative ways to bootstrap the model's ability to generate structured citations without any human annotated data. I think that's a crucial step towards making SelfCite even more powerful and broadly applicable.
I can't help but think about the broader implications of SelfCite. We've been laser focused on citations, but this seems like it could have a ripple effect on other aspects of LLMs as well.
Yeah, you're absolutely right. The success of SelfCite in improving citation accuracy through self-supervision really suggests that similar approaches could be used to enhance other aspects of the LLM output.
For example?
Well, imagine applying these techniques to improve reasoning abilities, or to ensure factual accuracy, or even to, foster creativity in writing. The possibilities are really vast.
That's mind-blowing. LLMs that can essentially fact-check their own reasoning. Right. Compelling narratives and, push the boundaries of creativity, all without needing, constant human intervention. It's like unlocking a whole new level of, AI autonomy and
capability.
And, while there are certainly challenges ahead, I think SelfCite provides a solid foundation and a spark of inspiration for future research in this direction.
I think that's a perfect note to end on. This deep dive into SelfCite has been incredibly enlightening, and I'm sure our viewers are buzzing with ideas and possibilities.
It's been a pleasure exploring this ideas and possibilities.
It's been a pleasure exploring this, groundbreaking work with you and our audience. Thanks for joining us today on AI Paper Podcasts.
And to our amazing viewers, keep those innovative minds working. Could be a self-supervised approach, like SelfCite be the key to unlocking even more, powerful and trustworthy AI systems. We'd love to hear your thoughts in the comments below. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI 255 EC.